Okay, 3.4 is the last sentence that we are doing. Then you're going to have a task next week. I'm going to post your review today in Schoology. So it'll be a book review, but I'm going to post it as a PDF for you. Then I'll post solutions to that as well. I'm still in the process, but I promise you I'm grading your test from last time. So I get that back to you soon. But review solutions, we'll review on Tuesday, and then we'll take our test on Thursday. Oh, is Wednesday an A day or a B day next week? Wednesday an A day? Okay. We'll review Tuesday and still take our test. So we'll review Tuesday and Wednesday because Wednesday was going to be like a work day anyway. So Tuesday, Wednesday review, Thursday test. All right, in 3.4, solving exponential and logarithmic equations. For the exponential equations, what you want to look for, see if you can express both sides as the power of the same base. Like, for example, you have 27 to the x plus 3, 9 to the x minus 1. You can rewrite 27 and 9 as powers of 3. That's going to be your easiest way for exponential if you can do that. But of course, not all of them you can rewrite with the same base. And so in that case, you either want to take the log, log, or natural log. So either take common log or natural log of both sides to use that power rule that you learned in 3.3 to get x out of the exponent area. If your base is 10, like let's say I had 10 to the x plus 3 equals some number, then you would want to use log since it also has a base of 10. And we use natural log if we have any other base. So if you can rewrite bases the same, easiest way. If not, more than likely you're going to take the natural log of both sides. For our purposes and in my lab, they're going to ask you to leave your answer in exact form and rounded. So you will need a calculator. Either you can use the one on your phone, and I'm gonna have calculators for you guys to use soon. I've got half of these over here that don't have batteries, and then half of them are with another teacher. So, but for today, I'll show you how to type them in using your phone or whatever. Log equations. For the log equations, you must check your answer. You cannot take the log or natural log of what type of numbers? Good. You cannot take the log of a negative number or 0. So make sure, for example, I would want to make sure that all of my x values are greater than what for this equation? Like once you solve this, if we continued solving it, and then we found that x was equal to -4, you know that won't work.
Good morning, Gerson High School. Please rise to the pledge. The flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. The Armed Services Vocational Aptitude Test will be given to Gerson High School on Thursday, December 10th, 2020. Any 11th or 12th grade student interested in signing up for the ASVAB, please go to your 11th or 12th grade Schoology group to access the link to the Google form to sign up. There is no cost to take the ASVAB. The link was also sent to Naviance, so you can access it there as well. The last day to sign up for the ASVAB is Monday, November 16th, 2020. The Junior Civitan Club members are selling basketball t-shirts in Miss Mayer's room, EE2533. Short sleeve are $15 and long sleeve are $20. Tonight is the first home basketball game at 7, and the team will be wearing this shirt in the pregame warm-up. We have a limited supply, so stop by to get your t-shirt today.
IT needs everyone to log out and restart their computers during lunch today. This is important to keep updates current and systems up and running properly. This year's No Place for Hate theme is equality and inclusion. And today's quote is, "Diversity is about all of us and about us having to figure out how to walk through this world together." Have a great day, Tigers.
Okay, so for log equations, what you're going to have to do there's two cases. One case, you need to condense down one side to have a single logarithm and the other side to have a constant. And then what you'll do from there is convert it to exponential form. So this would become, how would you convert this to exponential form? Base 4 squared equals x plus 3. And then you would solve it from that point. The second type of log equation you might see, you'll have log of stuff equals log of stuff. And you can use the equality property of logs and simply set your expressions after the log equal, and then solve from that point. Okay, we're gonna look at some exponential first, and then we'll look at some log equations. Solve and they're gonna ask you in math lab to express your solution in terms of natural log or common log, meaning just leave it exact, then obtain a decimal approximation to 2 places. So in number 1, we have 7 raised to the x minus 2 over 6 equals root 7. What would root 7 be in exponent form? Seven to the 1/2. Now that they have the same base of 7, what must be true about the exponents? They're equal. So once you have the same base, then you can set the exponents equal. What's your next step? There's a couple of ways you can go, but cross multiply is what I would do in this case. Make sure you multiply 2 to both terms on top. So that leaves you with 2x minus 4. Equals 6. And then from that point, of course, add 4, divide by 2, so x equals 5. Okay, number 2, how can you get 8 and 16 to be the same, to be a power of some base, power of the same base? 8 and 16 can both be rewritten as powers of what? What did I say? Good. You can rewrite 8 as 2 to the third power. Still is raised to the x plus 3. And then you can rewrite 16 as 2 to the fourth. And all of that is still raised to the x minus 1. What do you need to do with 3 and x plus 3 and 4 and x minus 1? An exponent raised to another exponent, you multiply them. So this becomes 2 to 3x plus 9. Right side becomes 2 to 4x minus 4. All right, is everybody okay with this so far? We good? Okay. Now that you have the same base, what do you do with your exponents? Set them equal. Should get x equals 13. Subtract 9. Add 4 to 9. Subtract 3x. Okay, in number 3, what's the first step that you need to do? You always need to isolate your base and your exponent as much as possible on either side. So add 2, and you get e to the 5x minus 3 equals 10,478. Okay, your base is e, and of course you definitely can't get both sides to be some power of e. So you need to take what of both sides? If your base is e, you're going to take the natural log of both sides. So this is what it looks like. What property can you use on the left side? What is your base here? Your base is e. And so remember that property, if our bases are the same, we're left with what's in the exponent area. So I'm just left with 5x minus 3 on the left side equals ln 10,478. Just keep bringing that down. That's just a number. It's just a value. So to leave our answer exact, and let's solve for x. So we have 5x equals ln 10,478 plus 3. And then, of course, divide by 5. And make sure you divide all of this by 5 or each term by 5. Either way you want to do it. This is the answer in exact form. We isolated x. We left everything exact. There's nothing that you can simplify any further on this side. Of course, if you could combine any like terms, you would do that, but you can't. When you type this in a calculator, you need to be really careful. So either get out the calculator that you have or the one on your phone. Okay, I would type in the top and then type in the top and then hit equal, then divide that answer by 5. If you type it in as ln of that number plus 3 and then say divide 5, it's just going to divide 3 by 5. You should get approximately 2.45 rounded to 2 decimal places. Okay, on 4, still exponential equation, can you get 7 and 3 to be the same base? I can't rewrite 7 and 3 to be the same power or power of same base of whatever. So in this case, you're taking the natural log of both sides. Why would you not take log of both sides? What's your base on both sides? 7 and 3. So you don't have a base of 10, so you can't take log. Okay, after you do that, your second step is always to pull what is in the exponent area, use that power rule, and pull it out front. And make sure that you put it in parentheses because you have 2x plus 1 getting multiplied to natural log 7. You have x plus 2, all of that getting multiplied natural log 3. Okay, we're trying to solve for x, and you have an x on both sides, and they're both multiplied to natural logs of some value. What you need to do in this case, you have to distribute natural log of 7 and natural log of 3. This is going to give you 2x natural log 7 plus natural log 7 equals x natural log 3 plus 2 natural log 3. And once again, natural log 3 and 7, they're just a value. So try not, I know it looks gross. You've got your x term here, and you have an x term on that side that you have to get together. And so it really doesn't matter which way you go. You could subtract 2x ln 7 and move it to the right side or vice versa. I'm going to subtract x ln 3 and move it to the left side. So get your variables on one side and move all of your constants to the other. So in that same step, I'm going to move this natural log 7, which is just a constant, I'm going to move it to the right side. All right, are y'all okay so far? Y'all have to talk to me. Did I lose somebody on any step? Okay, your goal, still trying to solve for x. Notice that now that I have my x terms on one side, notice that both of these have an x term. What can you do with that? How can you get x isolated from what you have? Can factor it out. So if you factor out x from this term, you're left with 2 natural log 7. Factor it out from this term, you're left with minus natural log 3. And now I have x multiplied to some number factored out of both of those terms. And now just bring this down. You can't combine any of this. They're not like terms. Okay, so we have one more step to get it in exact form. You're dividing all of this side, 2 natural log 3 minus natural log 7 by all of this. Okay, I know that looks gross, but that is your answer in exact form. That is as simplified as it can be. Okay, when you type this in a calculator to get your rounded answer, I would type it in all at one time, but you need to make sure that you put the top in parentheses and then divide and put the bottom all in parentheses. And then, of course, hit equal. Okay, you should get 0.09 rounded to 2 decimal places. That's definitely the hardest exponential problem that you're going to have. So took the ln of both sides, then you have to distribute that natural log, get your x's on one side, factor that out, and then divide. And you're going to have a pretty nasty looking answer. Okay, do you guys have any questions so far? Okay, I wanted to show you one like this. This is a quadratic type equation and exponential. All right, we'll factor like a quadratic. It's not necessarily quadratic, but notice it looks very much like the problems x squared plus 2x plus some number, whatever. And those always factored into 2 parentheses. So for this problem, you're simply going to divide this exponent by 2, and that will be your exponent of e in the front. So if I divide 4x by 2, I get 2x. Same thing as when you factored trinomials forever. This last sign is minus, so both of these signs will be different, plus minus. You're looking for two numbers that multiply to 18 that will subtract to 3. And so you've got -6 and +3. Okay, from this point, you solve this just like you did with trinomials. You take each factor and set it equal to 0. And solve each equation. Okay, when you isolate e to the 2x here, you get -3. E to the 2x equals +6. From this point, you need to take the natural log of both sides. Can you take the natural log of 3? -3. No, you can't. So once you see in either part where you've got natural log of a negative number or natural log of 0, you can stop. Like, that is not going to be a solution. For this part, when you take natural log of both sides, you get 2x equals natural log of 6. And so x equals natural log of 6 divided by 2. That's your exact answer. If they make you type that in, you're going to get 0.90. Okay, now we're going to look at a few log problems. Remember on log equations, when you solve these, you have to check your answer. All you do to check your answer is take the values that you find and only plug them into x plus 2 and x minus 1 in this case. If you get a negative answer in either part, you exclude that value. So of course, these are easy to check. You can simply say, okay, this number plus 2, is it negative or 0? Exclude it. Same thing. All right, on log equations, remember you're either going to have to condense to get one log on both sides, one log on one side and a constant on the other. If you have logs on both sides of your equal sign, that's when you try to condense and have log of stuff equals log of stuff and set the expressions equal. But I don't have a log on both sides. I have the logs on one side. So I want to condense this side as much as possible. Notice that these are subtracted. So how would you condense the x plus 2 and x minus 1? When things were subtracted, how did you condense them? Division. So you have log of base 4 x plus 2 over x minus 1. Now that we have it in this form, log base of stuff equals a number, from this step, you convert it to exponential form. So 4 to the first power, which is just 4, is equal to x plus 2 over x minus 1. Okay, cross multiply or multiply x minus 1 to 4. So that gives you 4x minus 4. And then you have 1 underneath 4, so you just have equals x plus 2. Subtract x and then add 4, so you get 3x equals 6, x equals 2. Okay, when you go back up and check that value, just simply plug 2 in both cases. 2 plus 2, 2 minus 1. It works. It's going to give you a positive value. Okay, you've got one in math lab just like this. 2, absolute value of ln of x minus 6 equals 0. Isolate your log as much as possible. So what 2 steps will isolate it? You add 6 and divide by 2. So you're going to get natural log of x equals 3. Do you guys remember from algebra 2 trig, how do you solve an absolute value equation? What should you set natural log of x equal to? What are the only 2 possible numbers that are going to give you that the absolute value of is 3? -3 and +3? All right, when you solve both of these for x, remember that your base of natural log was e. So you're going to convert this to exponent form. So e to the -3 equals x. And e to the +3 equals x. Okay, on 8, you have logs on both sides, but you need to condense the left side to only have 1 log so that you can set the expression or number equal to 112. So when you're condensing, remember that any numbers out front, you want to move them to the exponent area. So this becomes log of x squared and then just bring down minus log 7, log 112. Condense this even further. These are subtracted. So when you condense, divide those. Log of x squared divided by 7 equals log of 112. You can now set those expressions equal. So x squared divided by 7 will equal 112. And then start solving for x squared. So you get x squared equals 784. And take the square root of both sides. You get positive and negative 28, but which answer do you exclude? You exclude the negative 28 because if you go back up and plug in, you have log of x, and you can't have log of negative 28. So positive 28 is your only answer. Okay, last problem. The only thing that you need to write down is that equation. The formula models population of Texas A in millions T years after 2010. In part A, they ask you what was the population in 2010. So if this is your formula, modeling it after 2010, what is your initial population from this formula? Because it gives it to you. Remember that formula we had, the A equals PE to the RT? And P was always your initial. So what number is in place of P? 25.1. So if they ever ask you years after so-and-so, and then they say, what was population in that year? Just look at your formula, whatever number is in your principal amount place. So 25.1 million. Okay, in part B, they want to know when will the population reach 28 million? So you're finding T. Your accumulated value is 28, so that's what you plug in for A. You want to know when will it reach 28 million? So we're finding time. And I think in this problem, they're going to tell you like to wait until the end to round, meaning when you need to get E to that exponent by itself. So divide 28 by 25.1, but don't type it in yet and get a decimal. Okay, now we have E, the base and the exponent, isolated. So you have to take natural log of both sides to get T out of the exponent area. Okay, you'll have log of 28 over 25.1 equals, base is the same, so all of that cancels, you're left with 0.0187 T. When you type this in your calculator, type in log of 28 divided by 25.1 plus U, and then hit equal, and you're going to divide that answer by 0.0187 to get the time. Okay, if they ask you to round to the nearest tenth of a year, that would be 5.9 years. And of course, they ask you around to the nearest year of 6. right, work on your math lab, and if you have any questions, if you want me to work on with you, I'll be happy to.